set of parameter and all. So basically, this counting is part of all of topics of count. So how to count, that is the purpose of this topic, permutation combination. So how to count. So specifically, we have questions based on this topic. In every paper, you will find 1 to 2 questions based on this at least. At least 1 to 2 questions will be there. Yes, in a way, you can say whole math is based on numbers, and in numbers, most of the times we have to count only. Right, that's true, Akash. Yes, LRDA में भी exactly ऐसा ही आता है, count करना पड़ता है, बिल्कुल. So how to count? This is the basic topic, and there are various variety of questions in this topic. So that's how we are dividing this topic in several small parts. So let's start with the first one. So the first basic rule of counting, it is called fundamental rule or fundamental principle of counting. Okay? And as I said, this is very basic topic if you understand from very basic. And I will prefer not to use any big formula. We will learn the basics. Okay, so fundamental rules of counting, what is that? I will talk about that later. Triangle mix करते हैं तो yes, triangle भी आएगा, बिल्कुल triangle की भी बात हम करेंगे. So let's say there is a city A and there is a city B, and there are some roads connecting these two cities. This was road 1, let me call R1, or road 2, and another road 3. Okay, these are two cities A and B, and there are 3 connecting roads. Road 1 directly connects A and B, road 2 also directly connects them, road 3 also directly connects them. Now, obvious question, can you tell me number of ways to go from city A to city B? We don't want to repeat any road. We don't want to repeat any city. I need to start from A and reach to B. How many ways are there? 3. It's very basic thing. Now, you have not used any formula here. What are the 3 ways? Can you tell me, Vanshika? What are the 3 ways? Okay, Ankit is using a formula 3C2, okay, and Manshi is also using 3C1. But I don't wish to use any formula. That's perfectly fine. Divyansh is saying R1 se jao, ya R2 se jao, ya R3 se jao. These are the 3 ways, right? Use the path R1 or use the path R2 or use the path R3. That's it. These are 3 ways. Is it not? So no need to use any formula so far. No need to use any formula. Is it clear? Although that was correct. Somebody wrote 3C1. So 3C1, what it is, we will talk about it later. But that is correct. But it is not required. It is not required right now. It is simply there are 3 roads. Either use R1 or use R2 or use R3. That means at a time we can use only one of the paths. Yes or no? We can use only one of the paths. Pratyush, can't we discuss right now this PNC? In PNC, if you are going to discuss algebra, then this will be the remaining topic. This will left, isn't it? Yes, please right now focus on this topic. So whatever doubts are there, we can talk about that later. Okay, let's continue. So from A to B, there are 3 direct roads. So I can use either R1 or R2 or R3. That means out of these 3, I can use only one. Fine. So these are 3 ways, and the 3 ways are these 3 roads. Let's say there is another city C. There's another city C. And there are some direct paths here. So let me call this path 1 and path 2. Now, can you tell me how many ways are there to go from B to C? B to C जाने के कितने ways हैं? How many ways are there to go from B to C? Fast, please. Yes, it is 2. Right? And again, it's exactly similar question. The 2 paths are clearly P1 and P2. Use the path P1 or the path P2. So there are exactly 2 ways. Fine. No difficulty so far. Very basic thing. No need of using any formula. Now, if I ask you, how many ways are there to go from A to C? How many ways are there to go from A to C? Okay, Ankit says 6. Raghavendra ji bhi 6 कह रहे हैं. Many of you are, almost everyone. Anant says 5. Okay, some of you are saying 5, some of you are saying 6. Please write all the paths. Which are those 5 paths or which are those 6 paths? If there are 6 ways, tell me which are the 6 ways. If there are 5 ways, which are those 5 ways? Remember, I need to start from A and I need to reach C. That is my target. Priyanka, please write. What are those 5 ways? Rishabh has written R1, R2, R3, P1, P2. Rishabh, please listen. R1 ko use karke, can I reach C? No, R1 is not a way. Arey Baba, I need to reach C na. Yes, Venkat, that's perfectly fine. Excellent, Shubhangi, Aditya, many have written that. Good. Amulya, 12 kaise hue? Please write. It is not 12. Any, please think, how can you reach from A to C? If I want to go from A to C, I don't want to use any formula. I just want to understand what is happening. So some of you said 6, some of you said 5, and those who said 5, let me write. I saw one comment that R1, R2, R3, P1, P2. So these are 5. But by using R1, can I reach from A to C? No. By using R2, can I reach from A to C? No. So none of these paths can take me from A to C. So 5 is certainly incorrect. So what is the right way here? When I need to go from A to C, please understand very carefully. From A to C, where I need to go. So first I need to go from A to B, and then I need to go from B to C. So basically it involves 2 tasks. First task is go from A to B and then go from B to C. Yes or no? Yes or no? First I need to go from A to B and then I need to go from B to C. Right? Annie, is it fine? Those who are having any doubts, some of you are saying 5. Is this point correct? Till this point it is fine. There are two tasks involved, and the paths which you were mentioning, R1, R2, R3, and so on, so they are connecting either AB or BC. So when I need to go from A to B, I have 3 paths to use. I have 3 roads. I can use R1 or R2 or R3. So when I'm using R1 from A to B, so along with R1, now to proceed further from B to C, I'm having both the ways. So I can use along with R1 P1. So R1 P1 can be one of the combinations, or I can use R1 P2. So with R1, I have 2 options. Aditya, naya road banana nahi hai. We are using the existing paths, existing routes, and we are not repeating any of the path. Exactly, Akash, that's perfectly fine. कि A के हर route से आगे जाने के लिए there are 2 ways. So if I'm using R1, then there are 2 ways, P1, P2. If I use R2 in the first step, then again I have two further paths, P1 or P2. Again 2 paths, P1, P2. And same way for R3, again I have 2 paths, P1, P2. So total, how many combinations or how many paths are there? It's clearly 3 into 2, that is 6. Is it okay? Is it fine? Okay, so if anyone is having any doubt, please ask me now, because this is a very basic part and it is going to be used every time. So in this case, if actually what we have done, so we got this answer as 3 into 2, because for each of these 3 paths, we had further 2 paths to take, right? So this is 3 into 2, that is 6. So 6 is the total counting, and 6 paths we have already mentioned here. Many of you already wrote that in the comments. Clear now? Okay. Now Rimjim is asking, Rimjim I am seeing for a long time now, इसको formula में कैसे लिखेंगे? Formula I have not talked yet. Formula I have not talked yet, but wait for formula. थोड़ी देर के बाद करेंगे formula के बाद. Is it okay so far? Okay, let's move further now. मैं इसमें एक step extend कर रहा हूँ. I'm just extending. So I'm erasing this part and I'm drawing it again. या इसको रहने दो. I'm drawing the whole situation again. City A, city B, city C. So initially I had drawn the 3 direct paths between A and B, 2 direct paths between B and C, and let's say 1, 2, 3, and 4 direct paths between A and C as well. Okay? So now this is a new diagram. So question to all of you. Total, how many ways are there to go from A to B? We are not to repeat any city. We are not to repeat any city. That means by going from A to B, I can directly reach from A to B, or I can go to C first and then to B. Right? So there are 2 cases possible. Either I would be going directly to B, starting from A, or I can go first to C and then to B. So total, how many ways are there to go from A to B? Please take your time and answer correctly. Don't do mistake. And no useless talks now, please. I'm getting answer 10, 7, 3, 11. See, there can't be many answers for this one question. There's going to be only one answer. And I have not used any formula so far. I have not taught you any formula so far. So please be very basic. Think in a basic way. Okay, 11, 11, 11. Most of you are down to 11 now. Good. Akshat ji, question is that total how many ways are there to go from city A to city B? These lines drawn between any 2 cities represent the direct path between those cities. And only condition which we have used here is that no city should be repeated while going from A to B. So I can go from A to B directly, or I can go from A to C first and then from C to B. That's it. Rimjim 4 into 2, 8 कैसे आया? It's not correct. Still, I'm seeing different answers on the chat board. Renu says 24. Most of you are writing 11. Last chance. Jaldi say. Annie is getting 9. Ramu 10. अरे भाई ऐसे अलग-अलग क्यों? Why you are getting different values? Pranav 27 कैसे? How you are getting 27? Rutuja is also getting 9. Okay, I already told you that there are 2 situations possible. Either go directly from A to B, or we can take the path along C, via C, right? So these are 2 situations possible. I'm going from A to B directly, or I'm using the route A to C and then C to B. Is it fine so far? These are the 2 situations possible. I can go from A to B directly, or I can go from A to C and then C to B. Is it fine? I hope there should not be any doubt in this part. Okay, next. Now, first tell me, A to B number of paths, number of ways we can count. A, C, B also we can count. So what about these 2 ways? These type of ways are to be added or multiplied? We need to add them, right? We need to add them. There are some ways and some other ways. So for total we need to add them. We need to add them, right? Okay, now tell me from A to B, how many direct paths you can see here? From A to B, how many paths can you see here? It's clearly visible as we wrote earlier, let's say R1, R2, R3. So from A to B, either use R1 or use R2 or use R3. That means this one path or the second path or this third path. Total 3 paths. Yes or no? There are 3 direct paths. It's clearly visible. Plus, now I need to add these other ways in which first I need to go from A to C and then C to B. Right? Okay. A to C, how many ways are there? Please count and tell me. From A to C, how many ways are there? Remember, by going from A to C, there are 2 paths which are drawn at the top of the diagram, and there are 2 paths which are going down the diagram. So from A to C, there are 4 paths, right? A to C, 4 paths. And C to B. So C to B, there are 2 paths. So are these 2 paths to be added to this 4 or multiplied? We just did that earlier. In this 4, C to B wale 2 paths, that need to be added or multiplied? That will be multiplied. Yes, we just did that. See, for each of these 4 paths, there are further 2 ways to go from C to B. This it comes out to be 4 multiplied with 2. Any doubt in this point so far? Komal, these are the 4 paths. Let me call them maybe S1, S2, S3, S4. Can't you see from A to C? These are the S1, S2, S3, S4. These are 4 streets you can say. And from C to B, these are the 2 paths, P1, P2. Fine. Nishit, why multiply? Kaun batayega? We just did that, Nishit, in the previous question. We just did that. See, when I'm going from A to C, let me take the path S1. Please listen again here. Let me take the path S1 by going from A to C. Now, from after taking this path S1, I reached C. Now I need to reach B. How many ways are there with me? Starting with S1, then I can use either P1 or P2, isn't it? There are 2 ways. If I use S2, again 2 ways. If I use S3, then again 2 ways. I can use any of P1, P2. Same way, if I use S4, then again P1 or P2. Any of them can be used. That makes it, for each of these 4 paths, there are 2 ways further. That makes it 4 into 2 total, 8 ways. So 8 plus 3, that makes it total 11. Okay? Fine. Let's move further now. Let's move further. In the same diagram, please calculate and tell me how many ways are there to go from A to C. Total, how many ways are there to go from A to C? Please do it fast now. Please do it fast now. A to C. Excellent, Tulika, Anirudh, Harsh, good. A to C. Yes, perfect. 10 is the right answer. Now, while going from A to C, I can use a direct path, that is there are 4. Plus, I can go to B first and then to C. That means 3 into 2. So 6 plus 4 comes out to be 10. So this is the right answer. One more. How many ways are there to go from B to C? How many ways are there to go from B to C? Excellent, Abhishek. Nice. Excellent. Excellent. Most of you are getting it right. That's true. Imad, Narayan, Kashish. Good. Anjul. So while going from B to C, again, there are 2 direct paths available. Or if I'm going via A, so there are 3 paths up to A, and for each of these 3 paths, we have 4 further ways. So 3 into 4. So 3 into 4, 12 plus 2, that makes it 14. So I hope you have understood so far that when do we add the number of ways and when do we multiply? Is it clear? When do we add the things and when do we multiply? So this is the basic or fundamental principle of counting we need to be aware about. So when to add the 2 different ways and when they are to be multiplied. Now, can you put it in words? When we are to add कब करते हैं? Add कब करते हैं? Rishabh, can you explain Rishabh, you can be specific, please. What's your doubt? When to add them? So if we are to use either of these paths, at that time we are adding them. I repeat. So when we are to use either this task or that task, when we are to use either this path or that path, and to use exactly one of them, in that case we are to add them. But when we are multiplying, when we need to do both the tasks, see. So in this case, if I talk about B to C, so this was direct B to C, and this other one was B to A first and then C. So this BAC involved 2 tasks basically. I need to go from B to A and I need to go from A to C also, right? So when there are 2 tasks involved, which both have to be done, in that case, we have to multiply their individual ways. ठीक है ना? As in this case, while going from B to A, we could have used either R1 or R2 or R3. Out of these 3, I can use any way. So this is one way, this is one way, this is one way. We are adding them 1 plus 1 plus 1. That's how we are saying 3 ways. But now I need to go from A to C also. So whatever are the number of ways from A to C, that needs to be multiplied with that 3 into 4. So why they are being multiplied? Because for each of them, there are 4 further ways. So when both tasks are to be done, BA is to be done and A to C is also to be done, in that case, the individual ways are to be multiplied. So these are the two principles. Add for O. Yes, Ashu, thanks for putting it in words. So we add the things, we add the number of ways when we are to perform either this task or the other one. Or we multiply the number of ways when we need to do both the tasks. I need to do this task and this other task also. So this is the conclusion, exactly. Is it clear? Is it fine? So when both the tasks are to be done, in that case, we need to multiply. And if I need to do exactly one of the tasks, either use this task or do that task, in that case, we need to add. Okay, now let's move back to our original slide. So we're talking about fundamental rule or fundamental principle of counting. So now you can read it here. If first job can be done in M1 ways, second job can be done in M2 ways, and so on, another job can be done in Mn ways, then number of ways that all the jobs can be done. So all the jobs can be done. That means every job needs to be done. So they need to be multiplied. The individual number of ways needs to be multiplied. Fine. And the number of ways that either of the jobs can be done. That means either first job is to be done or second or third or fourth, like that. In that case, the individual ways are to be added. So that's what we have just discussed. Is it okay? That's called fundamental rule of counting or fundamental principle of counting. And if nothing is mentioned, whether things are identical or distinct, by default, we take the things to be different, distinct. That's a basic terminology. We will use it further. Fine. Let's move further now. Okay, now try to answer this question. Select any 3 out of 4 letters. These are 4 letters, A, B, C, and D. Select any 3. We just concluded the previous part. Yes, okay. I'm taking the screen back. This is already there. You can take screenshot if you wish. You can rewind your video also. Okay, let me move to the question now. Please answer this question. Select any 3 out of 4 letters, A, B, C, and D. How many ways are there? Okay, some of you have mentioned 4. Some says 12 also. Diksha ji, kahan se 24 bol rahi hain. Farhan, Pritam, they are using some formula, 4C3. Vishnu, 24 kaise aaya? Rahul, 0.67, what is that? Okay, most of you are writing 4 ways. Can you tell me what are the 4 ways? Can you please write what are these 4 ways? Excellent, Kavya, good. So Kavya has used very nice reasoning here. 4C3 is 4, that's perfectly fine. Yes, Tulsi, good. See, we need to select any 3. So while selecting, if I select first A and B and C, this is one way. So does their order matter here? First B ko select kiya, then A ko, then C ko? No, that order doesn't matter here. Right now, we are just selecting, we are not arranging them. So these are 2 things. When you talk about permutation, that actually means the arrangement. That actually means arrangement, where order matters. But this combination is basically selection. This is just selection. So here we are just selecting the things. So in selection, order doesn't matter. So there are 4 persons. Let's say there are 4 persons. I need to select 3 of them. So we are not arranging them in a line, right? So we just need to select them. So order doesn't matter. So I can select ABC, or I can select ABD, or I can select ACD, and finally I can select BCD. So these are the 4 ways, right? But here Kavya mentioned very nice way. In this way, if I'm writing, I can miss some case. There will be some mistake. So what is the easier way out? So out of these 4, I need to select 3. That means I need to leave one person or one letter, right? So I can leave either A or B or C or D. That's it. There are exactly 4 ways, isn't it? I can leave A, that means the remaining B, C, D are selected. If I leave B, in that case, the remaining 3 are selected. If I leave C, in that case, remaining 3 are selected. And same way, when I leave D, remaining 3 are selected, isn't it? Okay, now still many of you are very fond of formulae. I can see a lot of formulae there. Okay, let's come to that part also. Till this point, is it fine? I have not used any formula so far. We are just using the basic fundamental rules. We are just simply writing all the cases possible. Okay, now, as I just told you, that permutation means arrangement, but combination means selection. So the formula which we are going to use, they are just based on permutation and combination. There are some formulae for combinations, which is generally known as NCR. This is the number of combinations, or basically number of ways of selection of R different things out of N different things. So this is a very important part. Formula yaad karna aasan hai. You can remember the formula. But what does it mean? Most of the time students do not know that. So please make it very clear. NCR, what does it mean? It means number of ways to select R. Now this is the important point. R distinct things out of N distinct things. Okay? So NCR is number of ways in which we can select R different things or distinct things out of N distinct things. Is it okay? Is it clear? Okay, let me give you an example. Let me write the formula here also. NCR, the formula is, many of you are already using. The formula is n factorial upon r factorial into n minus r factorial. How did we get this? We will see it after some time. But right now I'm just writing the result. So it is NCR equals n factorial upon r factorial into n minus r factorial. I've just written the complete meaning of this phrase NCR. Is NCR का मतलब क्या है? I'm repeating. So it tells us the number of ways to select r distinct things, r different things out of n distinct things. So if you are having n different things, out of which you have to select r things. So number of ways will be NCR. And what is the formula for that? This formula is n factorial upon r factorial n minus r factorial. In whole PNC, this is the most used formula, or I should say this is the only formula in terms of formula if you have to use. Priyanka ji, this C refers to combination, means selection. Okay? It is C. This C refers to combination. That means selection. Yes, both must be distinct. That is the key point which most of the students forget. So don't forget that. Okay, let me ask you some question to clarify whether it is clear or not. I hope factorial all of you are familiar with. You can easily calculate that. Okay, if I'm having, let me say, 10 Red Bulls. In how many ways can we select one bowl? Number of ways to select one bowl, please tell me. Now 10 Red Bulls when I'm saying, so all Red Bulls are of same size, identical bowls. These are 10 identical Red Bulls. These all 10 Red Bulls are same. In how many ways can I select one bowl? In how many ways can I select one bowl? Please tell me. Many of you are saying 10. सोच के बताओ, ऐसा ही मत लिखो. Yes, Raghavendra, Kavya, excellent. Answer is 1, Shaurya, good. Why 10C1? Because you just have learned a formula. It's not correct. Arey Baba, there I mentioned these are the distinct things, but here I'm mentioning these are all identical balls. Formula can't be used here. Formula can't be used here. They are all identical red balls. ठीक है? Are you understanding? I said in the beginning only, अगर आप formulas के पीछे भागेंगे, if you run after the formulae, so you can remember formulae, but still you will not be able to answer correctly. So that's why, my dear students, I again request all of you, please think through very, very basic ways. Very basic. It's not a trap. It's unnecessary we are getting trapped. Tathagat ji, question is there, 10 identical red balls are there. In how many ways can you select one ball? There's only one way, because all the balls are same. Okay, if I ask you that, in how many ways can you select two balls? Please tell me now. In how many ways can you select two balls? In how many ways can you select two balls out of these 10 identical red balls? Durgesh ji बोल रहे हैं two ways. क्या-क्या two ways हैं Durgesh ji? Please think and tell me which two ways are there? Gungun with two ways. अरे two कौन सी ways हैं भाई? Yes, there are 10 identical red balls ना. These are 10 identical red balls. In how many ways can I select two of them? Only one way. कोई भी तो उठा लो ना. Arun, what are those 45 ways, Baba? It's exactly one way. Yes, there are same balls. Can you do balls? It's same thing. ठीक है ना? एक ही तरीका है. कोई भी दो balls उठा लो. Exactly. Now, still many of you are saying 45. Can you answer me when the answer will be 45? When there will be 45 ways? When the balls would be different. Okay, let me make it the chart here only. If these 10 red balls are different, 10 different balls, let's say, red का भी क्या करना है? If there are 10 different balls, then how many ways you can select one ball? If there are 10 different balls, then in how many ways can you select one ball? Please tell me. If there are 10 different balls, then in how many ways can we select one ball? Yes, if there are 10 distinct balls or different balls, then in how many ways can I select one ball? It is 10 ways. It is 10 ways, right? There are 10 different balls, ball 1, ball 2, ball 3, like that. So you select first ball or second or third or fourth. That makes it different because the balls are different. Now there are 10 ways. It is basically 10C1. Here we have to use this formula. Out of 10 balls, I need to select one ball. This is 10C1. Fine? This is 10 ways, right? Now, how many ways are there to select two balls out of these 10 different balls? In how many ways can you select two balls out of these 10 different balls? Arpita, तुक्के मत मारो भाई. How you are getting 45? Yes, it is 10C2, exactly. Now these are 10 different balls and I need to select two balls out of that. So the number of ways would be 10C2, which when calculated gives you the answer as 45. Is it okay? Is it clear to everyone? Akash, just solve it, na? 10C2. You know how to solve 10C2? Just apply the formula. So 10C2 would be 10 factorial. R is 2, so 2 factorial, and n minus r, that is 10 minus 2, that is 8 factorial. Fine. So 10 factorial means 10, 9, 8, 7, and so on. So 8 factorial part would be cancelled. So I will be left with 10 into 9 upon 2 into 1, which gives you 45. Okay? Is it clear to everyone? Any doubts so far, please? Any doubt so far? Aditya, I mentioned here 10C to 45 kaise? I've just applied the formula, nothing else. But if you are clear about this part, na, PNC is done. Yes, PNC is done. The most of students who commit any mistake is because of this jugglery only. They remember all the formulae, but कौन सा formula कहाँ पे लगाना है, कैसे लगाना है, what are the constraints? They don't bother about that. Kavya says we can also say that if first ball is taken, then the other ball can. Yes, good, Kavya, that's perfectly fine. Excellent, excellent. See, let me make another honest confession. In CAT, whatever questions has been asked from this topic permutation combination, most of them can be solved without using any formula. This NCR is the maximum thing which you may need to use, although this can also be avoided. But this is the maximum thing which you need to know, provided your logics are clear. Okay, so let's move further now. I hope till this point everything is fine. So NCR we have understood. So we have used the formula for combination so far. Permutation ka formula I won't like to discuss right now. Later we shall see. Till this point it is fine. So combination kya hai? We could have solved it like simple ways also. And if we are going to use the formula. So in this case, select any 3 out of 4. Can we say 4C3 here? In this question, can I say the answer is 4C3? Because out of these 4 letters, which are all different, I need to select 3. So answer would be 4C3, which comes out to be 4. Fine. Otherwise, without using formula also, by basic ways, we just counted the different ways. Is it okay? Okay, let's move further now. Here's the next question. Please answer fast. It's up to you now. If you wish to use any formula, or you can directly solve it. Please answer. In how many different ways a mocktail of 3 juices can be made out of 5 juices available? Yes, please. Thanks for that. I'm unable to answer every doubt in the comments. So those who have solved any questions should certainly help others. Yes, exactly. 5C3, perfectly fine. So there are 5 different juices available. And out of those 5 different juices, I need to select 3 juices and mix them, right? Now, order doesn't matter again. It is simply selection. So it is 5C3, which is 5 into 4, 3, 2, 1, right? 5 factorial upon 3 factorial, which is 3 into 2 into 1, into 5 minus 3, that is 2 factorial, 2 into 1. So 3, 2, 1 can be cancelled. So 1 is 1, so 2 2s are 4, 5 2, 10. ठीक है ना? Okay, before moving further, हमने फॉर्मूले की बात कर ही ली है, तो let me tell you one more thing. हम महक सिंह बिना फॉर्मूले के कैसे होगा? जब हम बिना फॉर्मूले के बताए थे, तब फॉर्मूला चाहिए था. अब फॉर्मूला यूज करा रहे हैं, तो बिना फॉर्मूला चाहिए. Okay, Kavya Mishra will come to help. Kavya ji, in how many different ways a mocktail of 3 juices can be made out of 5 juices available? Exactly. Ashu is perfectly fine. Bina formula, what we need to do? We need to select 3 juices. So that means 2 juices needs to be excluded, right? 2 juices are to be left. So which 2 juices can be left? So out of 5, let's say, let them call A, B, C, D, E. So first, if I'm leaving A, the other juice left can be B or C or D or E. These are 4 ways, 4 combinations. After that, if I'm leaving the juice B, then with A already we had made combination. So with B, the other juice could be C, D or E. So 3 more ways, right? Here there are 4 ways, then 3. Similarly, if the first juice to be left is C, then the other are 2 options only, D or E. That makes 2 cases. And same finally, D, E is the set of 2 juices which is left. So 4 plus 3, 7 and 2, 9 and 1, 10. So total 10 ways are there. Is it fine? Clear? Basically, we need to make cases. And by using formula, we are avoiding making cases. We are directly finding the answer. That's the difference. So both things are good. Yes, in games and tournament also you must have done. Exactly. LRDA wali baat hi na. Exactly. In games and tournament also you must have done similar things. Okay. Okay. Let's move further. Achha, in place of 3 juices, if it had been 4 juices, now what would be the answer? If it is 4 juices, now what would be the answer? In how many different ways a mocktail of 4 juices can be made out of 5? Answer please. Excellent, Abhishek. Yes, it is 5. Again, now we can use the formula. Formula will be 5C4, right? Out of 5 we need to select 4. Or we can say out of 5 we need to leave 1. That is the same thing. Or directly we can say 1 is to be left. So which one out of 5? Any one can be left. So basically 5 ways are there. So here I wanted to tell you one more thing. This 5C4, we can see it is equal to 5C1, as we are doing here in any cases. So out of n things, if we are selecting R, so number of ways are NCR, and it will be same for NC, N minus R, because after selecting R things, we are having N minus R things which are being rejected. So number of ways of selecting R things is same as that of number of ways of rejecting R things. So this is very important relation. NCR is equal to NC, N minus R. So directly I could have said 5C4 means 5C1, or 5C3 is nothing but 5C2. ठीक है ना? Is it okay? Okay, let's move further to the next question now. Now there are 3 questions. Let's do them one by one. First one, how many 3-digit numbers can be formed using the digits 2, 3, 4, 5, and 6 without repetition of digits? Now, this has nothing to do with the earlier part which we had just done. It's a totally different question. We need to make 3-digit number by using these digits 2, 3, 4, 5, 6 without repetition of any digit. How to answer this now? Yes, it is arrangement. Now order matters. Now order matters, right? Yes, Arno has already come up with the answer. 5 into 4 into 3. Good. Good. It is 5 into 4 into 3. Now, basically, this is a part of permutation. Earlier, you were doing combination, selection part. Now, this is a part of permutation or arrangement. Here, order matters. Yes, Tulika, that's true. We can write it as 5c3 into 3 factorial as well. See, without using any formula, first let's go by that. Without using any formula, I need to make a 3-digit number. So we have 3 places to be filled, right? We have 3 places to be filled. Now, any of the digit can come at this first place, right? Any digit can come at this first place. So this first place can be filled in how many ways? 1, 2, 3, 4, 5. There are exactly 5 ways to fill this first place. Yes or no? Right? There are 5 ways. Now, what is our task? We need to fill all the places. So we need to fill this place and this place and this place. That means whatever number of ways are here, we need to multiply it with number of ways to be filled to fill this second place, and we need to multiply this further with number of ways to fill this last place. Right? This is the principle of our multiplication. So this first place can be filled in 5 ways. So it can be either 2 or 3 or 4 or 5 or 6. Now can you tell me number of ways to fill the second place? Will it be again 5 or 4? Most of you are writing 4. Why can't it be 5? That's correct, Thagat. Yes, it is 4. That's true. Most of you are writing 4. Why not 5? 5 mein kya problem hai? What is the difficulty if I write 5 here? Yes, repetition will be there, right? If I would put 5 ways here, in that case, both the digits may be same, but question mentions that without repetition of digits, right? If it were not had been mentioned, agar ye mention nahi kiya hota, in that case, we could have taken same 5 into 5 into 5 also. But because it is without repetition, so 5 ways, then now 1 digit has been used, I'm left with 4 digits. So next place can be filled in 4 ways. Now 2 digits have been used, I'm left with only 3 digits. So this remaining place can be filled in 3 ways. So total 5 into 4 into 3, that makes it 60 ways. So there are exactly 63 digit numbers which can be formed by using these 5 digits. Fine. So I've not used any formula so far, right? We have not used any formula. Next case, next way. Now next way. See, I can divide this whole task in 2 parts. If I wish to use formula, now there's another way. I can divide this task in 2 parts. That first, these are 5 digits. I need to use only 3 digits. So to make 3 digits number, I need to first select the 3 digits, right? I need to select the 3 digits. So in how many ways can I select 3 digits out of these 5? So number of ways are 5C3. Is it okay? This is 5C3. So in 5C3 ways, we can select the 3 digits out of these 5. Fine. So whatever it is, we can calculate that 5C3 is 10 basically. It comes out to be 10. So in 10 ways, I have got the 3 digits. Now those 3 digits needs to be arranged. Now those 3 digits need to be arranged. In how many ways can you arrange the 3 digits? Let's count this. If there are 3 letters A, B, C. Total in how many ways can you arrange them? Please find out. Vinny, we had already discussed about that. Now we need to do both all these 3 tasks. I need to place the first place as well as the second place as well as the third place. All the tasks need to be done. That's why it is being multiplied. In the beginning part, we discussed that. Okay, so in A, B, C, in how many ways we can arrange them? So if A remains at the first place, then next place can be filled with B or C. It can be B or it can be C. If it is B, then the other part would be C. And if it is C, then it will be B. Okay, so with A, there are 2 ways. Starting with B, again, there will be 2 ways. Right? So B ke baad A, C or C, A. If I start with C, again, there will be 2 ways. A, B or B, A. That's how we have just made the cases. And if I count it like that only, so we have 3 places. First place can be filled in 3 ways out of these 3. And then next with 2 ways because we are not to repeat any digit, any letter. And then next in 1 ways. That comes out to be 3 factorial. Okay, na? So basically, whenever we are having, whenever we say ki n things are to be arranged, n things are to be arranged. Number of ways, let me write number of ways to arrange n distinct things. Tell me the number of ways. Now this is an important result here. Number of ways to arrange n distinct things. What should be the number of ways? It would be n factorial. Don't rush. I can see many of you are solving other questions. And again, side talks are going on. If you will not understand, you will remain wherever you were. Try to understand. It is n factorial. How do we get to know? Because there are n places. There are n places where we need to arrange these n different things. So first place can be filled in n ways. Next in n minus 1 ways. Then next in n minus 2 ways. And so on, which comes out to be n factorial. So this is very important and basic result. So whenever we are having n things, the number of ways to arrange them is n factorial. So as I was solving this question by using formula, so what we did, I divided the task in 2 parts. So first we are selecting 3 digits out of 5 in 5C3 ways. Now those 3 selected digits can be arranged among themselves in 3 factorial ways. So this becomes our answer. That is 10 into 6, that is 60. So the same question could be done like this also. Okay. हाँ repeat होता तो अलग बात होती. See यहाँ पे भी it was for distinct. Earlier also we used for distinct. अभी जब numbers same होंगे, letters same होंगे, in that case it will change. Right now whatever we are discussing it is for distinct things. Okay, it is for distinct things so far. Is it clear so far? Okay, and now the same question that out of 5 things we need to arrange 3 things. So that is called NPR. The permutation of R things out of N things. Arrangement of R things out of N things. So this is the direct formula here now. So it comes out to be N factorial upon N minus R factorial. This is N factorial upon N minus R factorial. So the same question could have been solved by using the formula for arrangement, NPR. So this NPR is N factorial upon N minus R factorial. So here it comes out to be simply 5PR, which means 5 factorial upon 5 minus 2, that is 3 factorial. Check here na? No, sorry, 5 minus 3, 2 बन जाएगा ना, it will be 2. 5 factorial by 2 factorial. That means 5 into 4 into 3, that is 60. Okay? So we have done 3 different ways to solve same question. Yes, ये permutation वाला भी distinct के ही लिए है. This is also for the distinct things. All these things are for distinct things so far. Okay? Yes, NCR was also for distinct things, NPR also for the distinct things. This formula are for distinct things. Okay, now let's try to solve the second question. How many 3-digit odd numbers can be formed using the digits 2, 3, 4, 5, 6 when each digit occurs at most once in any of the numbers? What does it mean? At most once in any of the numbers? Again, repetition is not allowed. Shubham, P means arrangement. In terms of formula, if you see, let me talk about this again. Wait. We just discussed about NPR, and prior to this, we discussed about NCR. Let's see it here now. What was the formula for NPR we just wrote? It was N factorial upon N minus R factorial. Fine. And what is NCR? It was N factorial upon R factorial into N minus R factorial. Right? Can't you see the difference? What is the difference? Difference is about this R factorial, extra R factorial in the denominator. Now, what does this NPR represents? It represents the number of arrangements or number of ways to arrange R distinct things out of N distinct things. Okay, out of N distinct things, in how many ways we can arrange R distinct things. And same way, this NCR is number of ways to select R distinct things out of N distinct things. Fine. So this is the thing we have discussed so far. So if you wish to go about formulas, so these are the formulas available, but no need to use every time, right? We can always avoid that. So we just solved the previous questions without using formula also, but wherever it looks beneficial to use the formula, then we can go about that, right? We can go for that, no problem. Is it okay? Is it fine, those who are confused about the 2 formulae? Okay, so going back to the previous question now. Now here it says how many 3-digit odd numbers can be formed. Now we need to form odd numbers, 3-digit numbers. So 1, 2, 3, 3-digit numbers. It should be odd. Now, formula doesn't know what is odd, what is even. Formula doesn't know that. So we don't need to use formula here. Directly we can fill all these places. So to become odd, what is the condition here? To become odd, what is the condition? A condition or constraint is there at the last place or one's place digit here, right? Yes, last place, there is a constraint. What is the constraint? To become an odd number, this last place must be an odd number. That means it can be either 3 or 5 only. Only 2 ways are there. Right? So first we need to fill that place wherever we are having some constraint. So this last place can be filled in exactly 2 ways, either 3 or 5. Is it fine? Right? That's the only thing. So we have filled this place in 2 ways. Now I'm left with 4 digits remaining. And for those 4 digits, there is no other constraint other than this part that they should not be repeated. So this place can be filled in 4 ways and then the remaining one in 3 ways. Right? So 4 into 3 into 2, that makes it how much? 24? So there are exactly 24 numbers which will be odd. Okay? Is it clear? Don't do any silly error. Okay, before I move to the next question, in the same question, if it asks about how many 3-digit, not odd numbers, I'm saying now multiple of 5. Multiple of 5. How many 3-digit multiple of 5 numbers can be formed using the digits 2, 3, 4, 5, 6, where each digit occurs at most once in any of the numbers. Now what is the constraint? Now what is the constraint? We want multiples of 4, multiples of 5. Exactly, last place there is only one way, and answer is 12. Good, most of you are writing it correctly, fine. Now in the last place, it must be the digit 5 only, so there is only one way to fill this last place. Exactly, last place will be filled by only 5. There is only one way. Now the remaining 4 digits can be filled anywhere. So this place in 4 ways and the another one is 3 ways. That makes it 12. Total 12 numbers are there. 12 3-digit numbers are there which are multiple of 5. Fine. Radha is asking, sir, in second question, first place per 4 kaise? Arey Baba, when we have filled 1 digit here, so we are left with 4 digits. So we are having 2 places. So one place can be filled in 4 ways, another in 3 ways. That's how. Okay. Now this last question here. How many 4-digit numbers which are divisible by 5 and are formed using the digits 0 to 5 without repetition? Now the digits which are allowed are 0 to 5. And this is 4-digit number. Please be careful and answer. In this question, 0 is also there. So make sure that don't do any mistake. Radha, is your query clear? Okay, for third question, 120, most of you are writing. 108 also, I see Deepshikha. Aditya says 96. Arey, different answer nahi aana chahiye. Please recheck. Please recheck. See, our objective is not to be the first person to answer. Our objective is to give the right answer. Okay, thanks, Radha. How to go about it? You are getting different answers. 120, 48, 96. कैसे करें से? How to do? Last digit 2 ways होगा. Tanishq says, okay, 2 ways क्या होगा? Either 0 or 5. That's what you are saying. First, let me erase the other things. Okay. See, we need to make 4-digit number, and we are having these 6 digits available: 0, 1, 2, 3, 4, 5. And the number must be multiple of 5. That is the condition, which are divisible by 5 or multiple of 5. So, constraint is there at any place? Where is the constraint in this case? Can you tell me at which place we have some constraint? The constraint is there at the ones place, right? Because we want the number to be divisible by 5. So in the last place, either it can be 0 or 5, right? But also there is another constraint for this first place or thousands place, because it can't be filled with the digit 0 also. Okay, so these are 2 constraints. Now, whatever difficulty we are going to get, it is because of this digit 0. So it's better you fix this place. Either I'm going to fill 0 here. This is one case which we have to simplify. And in other situation, we are filling 5 at the ones place. Okay, let's fix these digits in these places. Okay, if this last digit is filled by 0 or this last place is filled by 5. Let's count the 2 cases and then we can add the values. Okay. So if this last place is 0, so 0 is already used. Now I'm left with 5 digits, right? And now there is no constraint because 0 is already being used. So among the 5 digits, now in this place, can we fill in how many ways? 5, then next 4, and then next 3. That's it. So 5 into 4 into 3. How much it is? 5 4 is 20. 20 times 3 is 60. That is fine. So for this particular case, when the last digit of the number is 0, there are exactly 60 cases of 60 such numbers. Similarly, when the last digit is 5, so now 5 is gone, I'm left with these 5 digits, but this first place can't be 0. So now constraint remains at this place. So first we should fill this place. In how many ways we can fill this place now? It can be filled in 4 ways because 0 can't be filled, 5 can't be filled, 1, 2, 3, 4. These are the only 4 options. So this place can be filled in 4 ways. Is it fine? So this place can be filled in 4 ways. Now we have used 2 digits. This 1 5 is already filled, and this 1 digit here it is filled. So out of 6 digits, 2 have been filled. How many digits are remaining now? 4 digits are remaining. So this place can be filled in 4 ways, and then next one in 3 ways. So 4 into 4, 16, 16 into 3, that is 48. So it comes out to be 48 such numbers. So total comes out to be 108. So this is the right answer. Okay. So some of you already found that 108, but most of you were writing 120, and there were some different answers as well. I hope these all steps must be clear. Okay, now Nishit is asking combined batao sir. Combined kuch kar sakte hain isme kya? No. Diksha says, sir, please repeat last wala part. Diksha ji, I have made 2 cases that one's place digit is 0 or one's place digit is 5. If one's place digit is 0, then the other digits remaining are non-zero. Directly we can say 5, 4, 3, that's it. Finished. But when the last digit is 5, then this last place is filled by 5. Now I'm left with 0, 1, 2, 3, 4. So from these 5 digits, in how many ways we can fill this first place? I cannot put 0 here now. I'm only having 4 options, 1, 2, 3 or 4. That's how 4 into further 4. Why 4? Because 1 digit has been used, 5 was already used. So 2 digits are used, remaining are 4 now. Now 0 can be used anywhere, there's no issue. That's how it is 4 into 3. Okay, but now if you are using directly it as fill the last place in 2 ways, in that case, what was the difficulty? Difficulty was that the cases which you were making, in those cases, there were also some cases in which 0 was coming at the first place. So that was the difficulty. That was the difficulty. Okay, let me tell you this again. Why not combined part? Okay, let's discuss about the combined part. Now answer me. 0, 1, 2, 3, 4, 5. These are the 6 digits. We have to make a 4-digit number. And because it should be multiple of 5, so last place can be filled in 2 ways, 0 or 5. That's true. That's true. Okay. If I fill this last place in 2 ways, so 1 digit has been used. Now 5 digits are remaining. Now 5 digits are remaining. Can you tell me in how many ways can we fill this first place now? In how many ways can we fill this first place now? Why 4, Prerna? Only 1 digit has been used out of 6. So 5 digits are remaining now. Now 5 digits are remaining. Why you are saying 4? Chintan says 5. Arey Baba, 5 digits are remaining now. But issue is that among those 5 digits remaining, I do not know whether 0 is still left or 0 has been used. 0 is creating that problem. Are you getting it? 0 may have been used here also. In that case, it is 5 ways for this place. But if 0 has not been used, in that case, it will be 4 ways for this first place. So that's how directly we can't do it. And if we are doing it directly, in that case, there will be those 4-digit numbers which start with 0. There will be those numbers which start with 0. That will be the difficulty. Are you getting it? Exactly, good, Subhajit. That's perfectly fine. What Subhajit is saying, understood. That's a very nice thing. I was thinking whether should I talk about that or not. What Subhajit is saying, okay, let's count all the cases. So this place can be filled in 5 ways with the remaining 5 digits, then next in 4 ways, then next in 3 ways. That total comes out to be 120, which most of you got. Okay, na? But in this case, which numbers are not to be counted? Which are the wrong cases here? Which are the wrong cases here? The ones which start with 0, whose first place is being filled with 0, and in the last place, which have 5, isn't it? These are the cases. We start with 0 and end with 5 because they satisfy all the conditions and they are included in this 120. So these numbers need to be subtracted. How many such numbers are there? Let's count that. Only the middle 2 numbers are to be filled now, right? The middle 2 numbers are to be filled now. So out of these 6, 2 digits have already been used. So 4 are remaining. So it is 4 into 3. That is 12. So this 12 needs to be subtracted from this 120. Answer is 108. Is it okay? Excellent. Yes, Farhan, that's true. Second में 0 नहीं था ना? हाँ, thank you Aditya for answering that. Good. Is it clear? Nice. I was thinking whether I should discuss this or not, but when I saw one such comment, so that gave me motivation. Yes, we can discuss this. Nice. Okay, let me move further now. So enough time we have spent on this basic thing. So I hope now all the formulae are clear to you. NCR, NPR, what is their meaning, how to use and when to use, only when the things are distinct, or without using them also, whenever we are able to solve, we should solve, right? We should solve. So this is the thing which we have discussed so far. Let's solve some more questions now. Okay, please solve this first question. Find the number of words that can be formed using all the letters of the word Tuesday. How to do this? Please answer fast. First question, find the number of words that can be formed using all the letters of the word Tuesday. Perfectly fine, good. It is 7 factorial, nice. I hope it is clear to everyone. It is simply there are 7 different letters and they are to be arranged. We just discussed in the previous slide, a number of ways of arrangement of n different things is n factorial. It is simply 7 factorial. No need to calculate the value, by the way you can multiply and find out. So this is the right answer. Okay, let's move to the next question now. Yes, 5040 is the right value. This is 5040. Next question. How many words can be formed using all the letters of this word Tuesday which begin with T? It must start with T. Answer please. Yes, excellent. It is 6 factorial. Because now first place is fixed, it must be T, and now remaining 6 letters need to be arranged. It is 6 factorial, that is 720. Excellent. Next one. How many words can be formed using all the letters of word Tuesday which begin with T but do not end with E? Yes, be careful now. Which start with T but do not end with E. Please answer this one. Third question. Third question now. Third question, not correct. Meaningful नहीं लिखा बाबा. Meaningful कहाँ बोला है? हाँ, yes, Kavya, that's correct. It is 6 factorial minus 5 factorial. Yes, Shubham, that's true. 600. Good. See, the numbers, these words are starting with T. So remaining 6 places, 1, 2, 3, 4, 5, 6. If I count all this, which we have already done, it is 6 factorial ways, right? But out of these, we need to subtract those cases which start with T and end with E. That means remaining 5 places, 1, 2, 3, 4, 5. In how many ways we can fill them? In 5 factorial ways. So these 5 factorial cases need to be subtracted from this earlier one. 6 factorial was 720 and 5 factorial is 120. So subtracting them, we get our answer, which is 600. Is it understood? See, our purpose is not to just find the answer. It must be clear to you. If there is any doubt, I'm here to stop. I'm here to explain that. Clear? Achyut, is it clear? What does no mean? I don't understand. Yeah, 6 factorial minus 5 factorial, that's fine. Radha is saying, please repeat. Okay, Radha ji, The question asks, how many words can be formed using all the letters of the word Tuesday beginning with T? See, beginning with T part we had already done. When the number start, the word is starting with T, so this first place is already fixed. Remaining 6 can be arranged in 6 factorial ways, right? We did this in the last question as well. So out of this, what is the extra condition? That it do not end with E, right? But while calculating the 720 cases, so it includes those cases also in which the last letter is E. So we are counting those many cases and we are just subtracting it from the earlier ones. That's it. So 720 minus 120. Why 120? Because when first letter is T, last one is E. So remaining 5, the intermediate 5 can be filled or arranged in 5 factorial ways, which is 120. So after subtracting the 2, we got our answer. Okay, na? And similarly, now the last question. How many words can be formed using all the letters of the word Tuesday, which always begin with a consonant and end with the vowel? Now here's a constraint on the first 2 places again. In the intermediate 5 places, there is no constraint. For the first place, please tell me in how many ways we can fill this first place. I hope you remember what is consonant, what is vowel. A, E, I, O, U. They are called vowels. Hai na? So A is here, this is vowel. A, E is also here, I is not there, O is not there, U is there. That's it. So 1, 2, 3, there are 3 vowels. So in how many ways we can fill this first place? It should begin with a consonant. First place in 4 ways, because there are 4 consonants, right? And it should end with a vowel. So last place can be filled in how many ways? 3 ways, because there are 3 vowels. And the intermediate 5 places, 1, 2, 3, 4, 5, they can be filled with they can be arranged by the remaining letters now. So out of 7, 2 letters have already been used. So remaining 5 places can be arranged in 5 factorial ways, or basically 120. So this is 4 into 5 factorial into 3. This is 120 into 12. That is 1440. So 1440. Yes, that's true, Pranav, Arun. Is it okay? Okay, let's move further now. Good. Let's move further now. Again, similar questions. Please answer them fast. Now I'm not explaining, I'm just waiting for your answers. For the first question, please. What to do? We want all the vowels are together. Exactly. This Itu, good. We can treat all the vowels as one unit. In this first case, we want all the vowels should be together. So here A is a vowel, and then O is a vowel, and I is a vowel. So 3 vowels are there, or beside that 1, 2, 3, 4. 4 consonants are there. So total again 7 letters are there. So among the 7 letters, we have 4 consonants and 3 vowels. And in this question, it asks that all the vowels should be together. So all the 3 vowels can be considered as one unit, single unit. So basically 4 and 1, 5. 5 things needs to be arranged, right? So the answer should be 5 factorial. But among these 5 things, these 3 vowels, they can arrange among themselves in also in how many ways? 3 factorial. So answer comes out to be 5 factorial into 3 factorial, which means 120 into 6. Kitna ho gaya? 720. Is it understood? Can you tell me why did I multiply with 3 factorial extra? Why are we to multiply with this 3 factorial? A vowel hota hai na, bataya tha na abhi, A, E, I, O, U. A is a vowel. Okay, I'm repeating. Listen again. See, we are having this A, O, and I. These 3 are vowels, and these vowels must be together. So A, O, I, these 3 are vowels. They must be together. Beside that, we are having M, N, D, and V. So basically M, N, D, V, and this box. These 5 things needs to be arranged, isn't it? These 5 things needs to be arranged among themselves. So these 5 things can be arranged in how many ways? It is 5 factorial. That we have already done. Now, while arranging all these things in 5 factorial ways, this box containing 3 vowels is also there, and the vowels inside it can also be arranged, right? Suppose they are lying like this only, like this arrangement is M, N, D, V. They are together. Now this A, O, I, can it be remain in this order only, A, O, I? No, there are 6 cases possible. It can be A, O, I, it can be A, I, O, right? O, A, I, O, I, A, and same is starting with I. So I, O, A, or I, A, O. So basically all the 3 factorial or 6 arrangements for this vowels will also be there for every case in 5 factorial. That's how we need to extra multiply with this 3 factorial. So 5 factorial into 3 factorial, that gives us 720. So this is the answer here. Is it clear? Okay, let's move to the next question now. In this case now it says how many different words can be formed using all the letters of the same word so that vowels and consonants appear alternately. See, we are having 4 consonants and 3 vowels. Yes, question 2. Answer. It's easy question now. Yes, it is simply 4 factorial into 3 factorial. 24 into 6, 144, right? Yes, vowels can shuffle among themselves and consonant can shuffle among themselves. Right now, we are having 4 consonants, 3 vowels. They should be placed alternately. So vowel 1, vowel 2, vowel 3, and between them we should have consonants also. There are 4 consonants, so consonant 1, consonant 2, consonant 3, consonant 4, right? So they need to be arranged in this way only. 4 consonants, the word should start with the consonant and should end with consonant. And alternatively, we would be having 3 vowels. So now, which vowel is to be placed at which place? The 3 vowels can be arranged among themselves in 3 factorial ways. Simultaneously, the 4 consonants can also arrange among themselves in 4 factorial ways. Fine. So you can simplify. This is 24 into 6. That gives you 144. Most of you are getting that right. That's good. Third one now. How many different words can be formed using all the letters of this word such that no 2 vowels are together? Now, how to do this? No 2 vowels are together. Satyajit is saying पहले vowel भी तो आ सकता था क्या? सोच के देखो Satyajit. If in this case, if we start the word with vowel, so can all the consonants and vowel will be alternately? Try that. Radha, in which question are you feeling confusion? Tell me. No confusion. Wherever you are having confusion, please clear it. Otherwise, जैसे जो डर पहले का बना हुआ था वो बना रहेगा. I don't wish that earlier fear to continue. Exactly alternate नहीं हो पाएगा in that previous question. So for the vowels and consonants to be alternate, this is the only arrangement possible. The word should start with a consonant and end with consonant. Why? Because there are 4 consonants and 3 vowels. Now in this last question, it says no 2 vowels are together. How to do this? No 2 vowels are together. Most of you are saying 144, but how? How to solve this one? Let me think. So first arrange how we can arrange respectively consonants and vowels. And then we can shuffle the consonants among themselves and vowels among themselves, right? So some of you are writing 144, some of you are writing 288 also. Why same as before? See, in the previous question, no 2 consonants was also to be together, but now consonants can be together now. It should be more cases. It should be more cases now. So what can be done? See, the easiest way would be here. There are 4 consonants. So let's first put 4 consonants on the inner line. C1, C2, C3, C4. Fine. Let's take it like this. Let's take it like this. First, C1, C2, C3, C4. There are 4 consonants. Which one is C1? Which is C2? That we can arrange later. That we can arrange later. So right now, take it like this. So first time considering the 4 consonants, they are having no constraint. They are having no constraint. So they can be together. Between them, there can be vowels also. But tell me, if I need to put any vowel between 2 consonants, so maximum how many vowels can I put there? Between any 2 particular consonants, let's say between these 2, how many vowels can be inserted? Between these 2, how many vowels can be inserted maximum? 1, not more than 1, right? Not more than 1. So same way, if I place a vowel before C1, that is allowed, but maximum how many vowels can we put before C1? Again 1, not more than 1, right? So for vowels, we are having this 1 place, this 2nd place, 3rd, 4th, 5th. Among these 5 places, anywhere I can put vowels, but only 1 vowel at a place. Fine? So out of these 5 places, how many places I need to select for the vowels? There are only 3 vowels available. It is 5C3, right? So out of these 5 places, I need to select 3 places. I need to select 3 places where I can put the 3 vowels. Fine. So now the places for the vowels have been fixed. Places for the consonants have been fixed. So now vowels, the 3 vowels can be arranged among themselves in 3 factorial ways. And the 4 consonants can be arranged among themselves in 4 factorial ways. So this is our answer. Fine. So let's simplify this. So 5C3 is 10, 3 factorial is 6, and this is 24. So it is 1440. This is the right answer. Okay. Now Tulika is writing Bagger's method. I don't know the name maybe. Let me explain it again. Yes, I'm explaining it again. I'm ready for that. Don't worry. I'm ready to explain it again. This is an important thing, and this type of question in various other forms have been asked repeatedly in CAT. CAT में बहुत बार question पूछा गया है. The same idea has been asked in CAT repeatedly. Yes, Aditya, this is not tough. It's a good question. It's a different variety question. Okay, let us explain it again. The point was that, say if I say there are 5 boys and 5 girls. So these 10 persons go to a cinema hall to watch a movie. Okay? They go to a cinema hall to watch a movie and they book 10 consecutive seats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They got 10 consecutive seats. Fine. They got 10 consecutive seats. So my first question is that in how many ways they can be seated? No constraint. In how many ways can they be seated? Answer. In how many ways can they be seated? Please answer. It's 10 factorial, right? It's 10 factorial. No constraint. There are 10 persons, 10 seats available, 10 factorial ways. That's it. Second part. In how many ways can they be seated if all the girls are adjacent to each other? That's it. All the girls are adjacent to each other. All the girls are sitting adjacent to each other. Answer. All the girls are adjacent to each other. Excellent. This is 6 factorial into 5 factorial. See, it is as good as we did in the previous question. That Mondovi question was there now, when vowels were together. So all the girls can be considered as one unit now. So we are having 6 things to be arranged: 5 boys and 1 group of girls. So this 6 things can be arranged in 6 factorial ways. And for each of those ways, this group of 5 girls can be arranged among themselves in 5 factorial ways. So this is the right answer. ठीक है ना? Exactly. एक unit लेना है. We have to take 5 girls together as one unit. Fine. Next one now. Next one. In how many ways can they be seated if all the girls are together, all the girls are adjacent, and all the boys are also adjacent? Now, how many ways are there? All the girls are adjacent and all the boys are also adjacent. Preetham, first let's try to answer this one now. For that, I need to go back. Okay, Harsh has come up with the answer. Yes, Shruti, you missed to multiply with 2. See, when all the girls are adjacent, that is one unit. All the boys are adjacent, this group of boys is one unit. So these 2 units can be arranged among themselves in 2 factorial or 2 ways basically. And while each group can be arranged among themselves in 5 factorial ways. So answer is 2 factorial into 5 factorial into 5 factorial. Fine? Chicken? Okay, next one now. In how many ways can they be seated if no 2 girls sit together and no 2 boys sit together? No 2 girls sit together, no 2 boys sit together. Nishit, in second question, when all girls are adjacent to each other, that girls becomes one unit. They are to sit together. So 5 boys and 1 group of the girls. That makes us 6 things to be arranged. That's how we got 6 factorial. Okay, now this one. No 2 girls sit together, no 2 boys sit together. Is it 5 factorial into 5 factorial only? See, no 2 girls sit together, no 2 boys sit together. So they are to alternate. Not correct. Previous answer is correct. It is 2 times. Yes, it will be 2 times 5 factorial into 5 factorial. Yes, they need to sit alternate. They need to sit alternately, na? Aditya, think na. No 2 girls are to sit together, no 2 boys are to sit together. Both are 5 in numbers. So boy, girl, boy, girl, boy, girl, boy, girl, or girl, boy, girl, boy, girl, boy. That's it. That is the only way possible, right? So they can be BG, 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 BG like that. 1, 2, 3, 4, and 1 more set. Or it's reverse case, that is GB, GB like that. And in both cases, number will be the same. So it becomes 2 times 5 factorial, 5 factorial. ठीक है ना? Is it okay? So this is 2 times 5 factorial, 5 factorial. Because they have to be alternate certainly, but who is going to come at the first place? Whether it is a boy or it is a girl. So there are 2 cases possible. So accordingly, it is 2 times 5 factorial, 5 factorial. Now finally, the last question. If I only say, how many ways can they be seated if no 2 girls sit together? Now constraint is only on girls. Now on boys there is no constraint. Now on the boys there is no constraint. So how to do now? No 2 girls sit together. Now boys and girls need not to sit alternately. Now there is a constraint only on the girls. Now there is constraint only on the girls. On the boys there is no constraint. So as I was doing in the previous question, let's first make the boys take the seats. So 1, 2, 3, 4, 5. Boys have no constraint, right? Boys have no constraint. So let the boys sit. Let the boys be in their line of their 5 places, 5 persons, right? So for the girls now, between them, only at most 1 girl can be placed. At this 1, 2, 3, 4, 5, and 6. There are 6 places available, and at every place, yes, same process, same thing again, which we were doing the last question. So there are 6 places available, and out of these 6 places, exactly 1 girl can be seated at any of the places. I cannot put 2 girls between 2 boys, because in that case, 2 girls will be sitting together. Isn't it? So out of these 6 places, I need to select 5 places for the 5 girls. Or I can also say that out of the 6 places, 1 place is to be discarded. Because 5 are to be taken, so 1 is to be discarded. So which one to discard? Either the first one, second one, third, fourth, fifth, or sixth. There are 6 ways to fix up the positions. So the answer would be 6 ways to fix up the positions, and then 5 factorial ways to arrange all the boys among themselves, and 5 factorial for all the girls to arrange among themselves. Fine? Is it clear? Okay, now let me again ask one more question, which had appeared in CAT of similar variety again. There are 5 girls in a line. In how many ways 3 boys can be placed between them such that no 2 boys are adjacent to each other? Please answer this. There are 5 girls in a line. Okay? Let's say G, 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 like that. There are 5 girls in a line. Or 3 boys. In how many ways can 3 boys be placed between them? तो इनके बीच में कहीं पे भी हमें 3 girls को 3 boys को place करना है. When I'm saying between them, so it can be at either of the ends also. That is also allowed. So such that no two boys are adjacent to each other. No 2 boys are adjacent to each other. Exactly similar question. What would be the answer now? See, girls are already arranged. Girls are already in this line. So girls need not to be arranged now, but the boys needs to be arranged. So first we need to fix up the places for them. So as we did earlier, for these boys, between any 2 girls, I can use only one place. So 1, 2, 3, 4, and again 5 and 1, 6. So out of these 6 places, I need to arrange these 3 boys, right? I need to select the 3 places where these 3 boys can arrange among themselves. So 6C3, we can select the 3 places, and those 3 boys can be arranged at those 3 places in 3 factorial ways. So this is the answer. Fine. Yes, it is 6C3 into 3 factorial. Okay. So I'm discussing same thing again and again with different numbers, different scenarios. That's it. It is 6C3, not 65, yes. In 10 seats, how are we arranging 11? That's a good doubt. Jeet is asking in the previous question, so how it is 11? See, Jeet, that we are not arranging 11 places. In this case, 5 boys were made to stand here. So when we have fixed up the 5 places for the girls, then we are having total 10 persons. They will be sitting in the 10 seats only. It's not 11. I repeat, suniye dhyan se. In this case, I assume that we are considering the end places also. If I need to go with this thing between only, then we can discard the end positions. Right now, I am considering the end positions also. That's why I've taken 6C3. Otherwise, we could have left the extreme positions. Then it would be 4C3 in that case. That's fine. Okay. Gia is asking why not multiply with 5 factorial? Because 5 girls are already there in this line. They are not to be arranged now. Right now, they are not to be arranged because they are already there. Is it fine, Chandru? Many of you are asking that why we are not doing 5 factorial here. Because the 5 girls are already there in that line. They are already arranged. We are not to arrange them now. Okay, so when it is to be arranged, then we can. If it is not, then not required. Is it okay? So this point, there are no 11 places. There are 10 places only. There are 10 seats only. So these 10 persons, when we have fixed up their places, those 10 persons will be sitting in these 10 seats only. That's how. Okay, let's move further now. Okay, try to answer this one. How many different words can be formed using all the letters of the word Mandovi such that the consonants appear in alphabetical order? We had already seen that there are 4 consonants, M, N, D, and V. There are 4 consonants and 3 vowels. So in how many ways they can be arranged so that consonants appear in alphabetical order? Answer, please. Real question में given है ना? It is given in the question that 5 girls are already there in the line, so they need not to be arranged. But boys are to be placed, so their arrangement is to be considered. That's how. Okay, I'm getting different answers here. Kavya, Vedanti, अलग-अलग answers हैं. Please check carefully. How many different words can be formed using all the letters of this word? Consonants appear in alphabetical order. Okay, what's your answer? 4 into 3 factorial, 12. How you are doing it? I don't think it is correct. How you are getting this? Everyone is getting different answer. Yukta, 7C4 into 3 factorial. That is perfectly right. Good. 7C4 into 3 factorial. That is the right answer. 7C4 into 3 factorial. See, Farhan, taking consonant as a single unit, it doesn't say that consonant must appear together. It doesn't say that. It only says that consonant appear in alphabetical order. It is possible they are placed at different places. The consonants are placed at different places. It is possible, but they must be in alphabetical order. That is required, right? That is the only thing which is required. So correct answer is 7C4 into 3 factorial. See how to do it. Now listen please carefully. I can see there's so much distraction. I don't know why. There's nothing to calculate. It's a very simple thing if you pay attention. Now listen carefully. This is the right answer. I was looking for that only. See, as somebody mentioned, taking consonant as one unit. So we are not supposed to make all the consonants appear together here. We only want that consonants must be in alphabetical order. So the easiest way here is that out of the 7 places, I want 4 places where to place these consonants. Yes or no? There are 7 places available. 1, 2, 3, 4, 5, 6, 7. So out of these 7 places, I want 4 places. I want 4 places where the consonants would be placed. Is this fine? Those 4 places can be adjacent. They may be any places. So I can select any 4 places in how many ways? 7C4. Fine. Now, these 4 places we have selected for the consonants. Can you tell me in how many ways the 4 consonants can be arranged on these 4 places? I repeat, in how many ways can we arrange those 4 consonants in these selected 4 places? Only one way. Why that? Why that? Why so? Because the order is already fixed. They must be in alphabetical order. They must be in the alphabetical order. Condition is already there. That means number of ways to arrange the consonants is fixed. It is 7C4. That's it. And the remaining 3 places, the 3 vowels can be arranged in 3 factorial ways. So that's how this is the required answer. Is it okay? Yes, consonants are all different and they need to be arranged in alphabetical order. So the order is fixed. हाँ मैं दोबारा बताता हूँ, सुनिए ध्यान से. Please listen carefully. This is a good question and it is not difficult part if you pay attention. It's the same situation, same scenario, just by changing the conditions slightly. Some questions appear to be very easy, some questions appear to be difficult. So I'm repeating it. I'm repeating whole step once again. The condition was that the consonants appear in alphabetical order. Okay? So consonants must be in alphabetical order. We are having 4 consonants because they are all different. It is M, N, D, and V. So alphabetical order ka matlab, they must be certainly in this order. D should come first, M should come afterwards, N should come after that, and V should be at the last. Now these 4 consonants need to be placed in this order only. So at which 4 places can they be placed? Select the 4 places for them. Fine. Select the 4 places for them. In how many ways we can select 4 places for these 4 consonants which are to be placed in this order? That is 7C4. Out of these 7, select any 4 places. Right? Maybe the selected places are, for example, let's say this place has been selected. Maybe this is the second place to be selected. Maybe this is the third place to be selected, and this is the 4th place to be selected. That can be one of the selections. Now, in these 4 selected places, I need to put these 4 consonants in this order only. So this is D, M, and V. Their position is fixed. D, M, and V. So this was one of the cases out of 7C4. There can be many more. So total 7C4 cases are there, and for every case, position of D, M, and V is fixed. Fine. And in the remaining places, we are to fill the 3 vowels, and they need to be arranged also. So that arrangement of vowels can be done in 3 factorial ways. That's how. ठीक है? See, I don't say that you will be able to become comfortable with the topic or not. As I said in the beginning only, you need to think clearly. So if you are thinking clearly, then you can understand that this much I have understood, and this is what I'm unable to figure out, how to cope up with the given condition. So whatever is the given condition, whatever is the given constraint, we need to satisfy that. Accordingly, we have to solve. Don't guess randomly. Don't apply a formula randomly. No, that is not going to help. Is it okay? Let's quickly move to one more thing. Can you do this answer? This is the last one now. Time is already up. Time is about to over. Let's solve this last question for the day. Actually, we were supposed to cover much more syllabus today. I've just spent a lot of time in explaining all the questions because it was doubtful. It was a difficult topic for many of you. And I hope you are getting something by now. Okay, what is the sum of all different 4-digit numbers that can be obtained by using the digits exactly once? First, can you tell me total how many numbers can be formed here? How many 4-digit numbers can be formed by using all these 4 digits? Quickly answer this. 4 factorial, good. Total 24 numbers can be formed, right? It is simply arrangement of the 4 different things at 4 different places. 24 numbers. Now, question is asking about sum of those 24 numbers. We have to find the sum of those 24 numbers. How to do this now? Sum of those 24 numbers. Now, to do it easily, there's some formula also. I will try to avoid that. Yes, you should always revise, Anurag. There is no doubt in that. Okay, I'm not going for any formula again here. Now, listen. Total 24 numbers will be there, that's for sure. You know that it is 4 into 3 into 2 into 1. Now 4 places, first place can be built in 4 ways, then 3 ways, then 2 ways, then 1 way. So total 4 factorial 24. There are 24 numbers. Now question is asking about sum of those 24 numbers. We are not to find sum of digits. It's not sum of digits. We have to add the numbers. Arey baba, smallest number kya banega isme? Can you tell me what is the smallest 4-digit number that you can form here? Smallest 4-digit number kya hoga? What is the smallest 4-digit number? It's 2457, right? And what you are saying 18 into 24, it is less than that. This is the smallest number. And largest number which you are forming is what? That will be reverse of this, that is 7542. So all these 24 numbers are to be added. Sum is going to be a big number, right? It is certainly going to be more than 4-digit number, isn't it? So our target is to add all these numbers, and it looks tedious task, right? Just one clue. Tell me at ones place here, the digit 7 is appearing, digit 2 is appearing. Will 4 be also there? Yes, of course, 5 will also be there. You have to tell me which digit will appear maximum number of times at one place. I repeat, my question is, which digit will appear maximum number of times at this units place or ones place? Which digit will appear maximum number of times at the ones place? Please answer my question. Aditya Singh Tomar, I already told this is the last question. Why are you wasting time? Please answer this. Equal, yes, thank you, Tulika. All the digits will appear equal number of times, right? No digit is being used partially. We are not partial about any of the digits. So all the digits would be appearing at one place equally, right? Can you tell me how many number of times each digit will appear? How many times each digit will appear at the ones place? Remember, total 24 numbers are there. Total 24 numbers are there. And you have just told that each of these 4 digits would be appearing equally. So sab kitni baar aayenge? 6 times each, right? That means if I add all these unit digit values, what will be the sum? It will be 2 plus 4 plus 5 plus 7, 6 times, isn't it? This is 9 plus 9, 18. 18 into 6. Mukul ji, total 24 numbers hai na? Sab 6 baar aayenge, tabhi to 24 banega, isn't it? So this comes out to be 108. Is it okay so far? Excellent. Thank you, Chintan. So sum of all the unit digits comes out to be 108. So 8 and 10 carry, right? 10 carry. Now, similarly, can you tell me fast what will be sum of all tens place values? What will be sum of all tens place values? Again, same thing. It's again same thing, isn't it? Again, all the digits will be appearing equal number of times. It is again 108. So 108 plus 10. 108 plus 10 previous carry it is, right? That makes it 118. That is 8 and 11 carry this time. Fine. And similarly for hundreds place again, 108 plus 11. So 108 plus 11 for the hundreds place, it becomes how much? 119. So 119. Again 11 carry. First say 108 plus 11. So 190. So this is the right answer. 119988. Fine. I have not used any formula. We have simply added the values. Final thing. You just add these two numbers. What do you get? If I add this first number and last number. If I add this first number and last number, it is 9999, isn't it? If I take the second number and second last number, try to write and add them. Again, you are going to get the same sum. So pair-wise, every pair of last first and last, second, second last, these numbers are having same sum. So how many such pairs we are going to get? It is 12. Because total 24 numbers are there. So 12 pairs we are going to get here. Fine. You can just do this and get your answer. Is it okay? That's true, Venkat. Fine. So we shall end it here. So we discussed the various aspects of this permutation combination. This is the art of counting. We discussed about combination formula. We discussed about permutation formula. Without using formula also we solved the thing. How to arrange n different things at n different places. That is n factorial ways. So all these different things we did and various questions also we practiced. So that's all for today and we shall continue the topic tomorrow. Fine. Thank you. And numbers will not end up to be equal, then we can't use it. Why will it will not end up to be equal? If there is some carry involved. Right now there is no carry. 7 plus 2, 9, 5 plus 4, 9, 4 plus 5, 9, 2 plus 7, 9. Right? In place of 7, you will shuffle 5, 7 and here you will shuffle 2, 4. It will come out to be same always. But in the case when there is carries, some carries involved, then this value will change. So right now it is not the case, that's how we can use it. Okay? So we shall end it here. So thank you very much. Thank you for your patience and I hope you are able to solve something now. हाँ डर पूरा चला जाए ऐसा तो शायद ना हो लेकिन डर नहीं रहेगा अभी डरने की बात खत्म हो जानी चाहिए ओके थैंक यू वेरी मच थैंक यू एवरीवन साबिना तक्षा तनुष्का यू क्या भाई शिल्पी मुकुल 12 कैसे आया अरे भाई मुकुल टोटल नंबर ऑफ नंबर्स आर 24 ना एंड इफ आई एम मेकिंग पेयर्स ऑफ टू नंबर्स टुगेदर तो 24 में से दो का एक पेयर दो का एक और पेयर दो का एक और पेयर सो टोटल हाउ मेनी पेयर्स दैट विल बी 12 इजंट इट आज तक इस टॉपिक को नहीं पढ़ा था अब सम्स बने कुछ तो श्योरली आई बेनिफिटेड फ्रॉम दिस सेशन थैंक यू ग्रेट सेशन थैंक यू इट्स ग्रेट पार्टिसिपेशन एंड दिस पार्टिसिपेशन कुड हैव बीन बेटर मैं आपकी झूठी तारीफ नहीं करूंगा बीच में आप बहुत डिस्टर्ब करते हैं भाई इफ यू बिकम लिटिल बिट मोर अटेंटिव दैट इज गोइंग टू बी बेनिफिशियल फॉर यू थैंक्स यशी दैट्स गुड क्वेश्चन समझ में आए ओके थैंक यू एवरीवन सो वी शैल कंटिन्यू दिस टॉपिक टुमारो There are many more things to be covered, many different varieties of questions to be done. So I shall end it now. It's okay, Akash. बच्चे ही ऐसा करते हैं. But don't at the cost of your own learning. Don't do it at the cost of your own learning. Don't hamper it. Okay, thank you everyone. Good night. Good night. Algebra का marathon कब होगा? I'm not sure about that. I have not been informed yet. मुझे नहीं मालूम है अभी. अच्छा, यू आपका नेम ही है. Good. Okay, fine. So I shall end it now. प्रीतम saying something 9999 into 12 method किया सब same questions में काम आएगा. अरे मैंने बताया ना, when there is no carry involved, you can check ना. That's why I told you just check. So because there was no carry involved in the addition process at any step, that's how it works. But there can be some different digits, in which case the carry will be there. So then we can't use this because the sum will not be same. Okay, so it will not be helpful every time, but the method which we used earlier, that is useful every time. And for this part, people have made various formula also, but I try to avoid every time. Okay, इस sum वाला method काफी बार आपको काम आएगा, but may not be useful every time because of the carry. ठीक है? Okay. Any more thing? First method is universal. Yes, you can say that. Okay, bye Subhajit. Rupesh, why have we taken largest and smallest? I just wish to tell you that sum is same. That's why. That is the only thing. Okay, Radhe Krishna, Hare Krishna. Good. Bye. Okay, bye everyone. Good night. I'm ending it now. Thank you.